Cosmic explorers, welcome to a journey beyond imagination. Today we embark on an awe-inspiring voyage through the vastness of space, unveiling the wonders and mysteries of the Titanic collision between our Milky Way and the Andromeda Galaxy. At approximately 2.5 million light-years away, the Andromeda Galaxy is our Milky Way's largest galactic neighbor. It spans an incredible diameter of about 220,000 light-years, making it nearly 2.5 times larger than our Milky Way. This vast expanse is home to billions of stars, along with an abundance of gas, dust, and various celestial wonders. If you haven't already, be sure to check out our video on Andromeda Galaxy for more. Link is in the video description. It has long been known that the Andromeda Galaxy is moving toward the Milky Way, but it was unknown whether the far future encounter will be a miss, glancing blow, or head-on smash-up. Researchers used the Hubble Space Telescope to measure the positions of stars in Andromeda in 2002 and 2010, relative to hundreds of distant background galaxies. By analyzing the combined data from 15,000 stars, scientists were able to calculate Andromeda's precise movement through space. This investigation yielded a significant revelation: the two galaxies will collide head-on. Galaxy collisions are relatively common on cosmic timescales, especially considering the vast number of galaxies in the universe. However, these collisions occur over millions to billions of years, making them less frequent on human timescales. Observations from space telescopes like the Hubble Space Telescope and James Webb Space Telescope have provided valuable insights into the complex and dynamic interactions occurring between galaxies throughout the universe's history. This NASA animation vividly simulates the collision course, spanning 2 billion years of evolution. 4 billion years from now, the two galaxies will pass through each other, and 2 billion years after that, they will fall back in a permanent embrace to form a single galaxy. While it might sound dramatic, the actual interaction between these two massive galaxies is more of a slow gravitational dance than a fiery collision. When two large spiral galaxies merge, the result will likely settle into a cloud-shaped elliptical galaxy. Most elliptical galaxies observed today formed from collisions that occurred billions of years ago. Inspired by the dynamical computer modelings, scientists also created a series of photo illustrations for the Titanic collision. This is a nighttime view of the current sky, adorned by the radiant ribbon of our Milky Way. The Andromeda Galaxy graces the scene as a subtle spindle. At the 2 billion year mark, the gravitational tango between these galaxies draws Andromeda nearer, enhancing its prominence in the sky. And the approaching Andromeda Galaxy's disk expands notably larger. Fast forward to 3.75 billion years, Andromeda unfurls to dominate the field of view, while the Milky Way shows distortion from Andromeda's gravitational pull. Between 3.85 and 3.9 billion years hence, during their initial close encounter, the hydrogen present on their disks of these two spiral galaxies is compressed, producing strong star formation. The sky ignites with newborn star formations, evident through an array of emission nebulae and youthful star clusters. As the second close passage unfolds at 5.1 billion years, the Milky Way and Andromeda cores emerge as twin luminous lobes. Yet the presence of star-forming nebulae diminishes, due to the depletion of interstellar gas and dust caused by previous bursts of star creation. Finally, at the juncture of 7 billion years, the conjoined galaxies birth a colossal elliptical galaxy, radiating from its luminous core and dominating the nocturnal canvas, and nebulae no longer grace the celestial expanse. The aging stellar population, once aligned in a plane, now populates an ellipsoidal volume. Even though the Andromeda Galaxy contains around 1 trillion stars, and the Milky Way contains roughly 300 billion, the probability of even a single star collision remains exceedingly low due to the vast expanses separating them. For example, the closest star to our Sun, Proxima Centauri, lies approximately 4.2 light-years away. To visualize this scale, envision the Sun as a ping-pong ball, with Proxima Centauri resembling a pea situated about 680 miles away. In this analogy, the Milky Way's expanse would span about 19 million miles. Even though stars are more densely concentrated near the cores of both galaxies, the typical distance between stars remains an astonishing 100 billion miles. To put it into perspective, picture a ping-pong ball spaced every 2 miles. Consequently, the likelihood of any two stars from these merging galaxies colliding is extraordinarily remote. According to current calculations, scientists anticipate a 50% probability that, within the merged galaxy, the solar system will be displaced to a distance 3 times greater than its current distance from the galactic core. Additionally, There is a 12% likelihood that the solar system will be propelled out of the newly formed galaxy at some point during the collision. It's important to note that such an occurrence would hold no negative impact on the system, and the likelihood of any disruption affecting the Sun or its planets could be quite low. We hope you enjoyed the video. Be sure to hit that like button and subscribe to our channel. See you in the next video.